Hello, everyone. How's everyone doing? Thank you all for joining. Welcome to InRhythm Quarterly Summit. For those who don't know me, I'm Parag Katkar. I'm the head of consulting practices at InRhythm. As a part of InRhythm's Quarterly Summit, we are hosting a series of hands-on interactive coding workshops on the latest technology trends. And today we are hosting the fifth workshop of this series, which is our Android workshop. Learning and growth is a core value for us at InRhythm. And the thought leaders at InRhythm identify the latest industry trends for each of our practice areas. They plan weekly lightning talks on those trends. And at the end of every quarter, we host a quarterly summit where we go over the summary of the technology trends that we covered in our lightning talks for that quarter. And we do hands-on coding workshops to learn those skills where we all discuss the learnings and share the knowledge from our practitioners on how they would apply these new skills that they learn to the products and platforms that they're building. So I'm super excited for today's workshop. Without further ado, I'm going to hand it over to Greg, who is our Android practice lead, to go over the agenda for today's workshop. Take it over, Greg.
Thank you so much, Parag. So everybody, my name is Greg. I'm the Android practice lead here at InRhythm and excited to be having this workshop today with everybody. I think Parag covered mostly the high level of what these are and what we do. So I'll just kind of go over our overall schedule. So for today, we are currently in the welcome phase, obviously, 1:30, 1:45. We're going to give an introduction about what we're talking about. Then at 1:45, our first talk for the day will be Daniel Olatoye. He'll be giving us a conversation about what is KMM, what is multi-platform, what should we look at it for, what's even the point of it. The end of his discussion will also be setting up our development environment to start coding KMM to help us out for the rest of the day. Between each talk, we are then going to have breakout rooms where we can get into smaller groups and help each other code up to get to where we left off on the chat. So the hope is as we do one chat, then we have a breakout room, we all code it up. Once we're all done coding it up, we start the next chat, which starts pretty much exactly where the last chat left off. After we do our Hello World setup, we're going to be handing it over to Satish Yadav, who will be showing us how to set up the core KMM module and implementing some APIs for us to be using across platforms. Then we'll be breaking out again into some smaller coding rooms. We'll have a 15-minute break at that point to grab a cup of coffee, socialize a little bit, and then we'll go into our third and final talk, which will be Jerrell showing us how to use that core logic and using it in an Android application, as well as briefly showing us how to consume it in an iOS application. From there, we'll have another 30 minutes of coding up everything we see. And at the very end, we'll do a demo, discussion, Q&A, socializing, fun stuff like that. So that's our general overview for the day. And I'm super excited to be introducing and having these talks today. As a prerequisite for what we want to do is for anybody wanting to follow along and code with us, the hope is that you have Android Studio installed, hopefully. And for our project, our minimum SDK is going to be 24 and our target SDK is going to be 33. For anybody who knows Gradle, you know how to set that up and you know what that's going to mean. And just for the sake of our work, an Android emulator or a plugged-in device to be running it on. Now, we also have our Summit website, which I'll be posting that multiple times in the chat as needed. But our page there, summit.inrhythm.com/Android, has overviews of everything we're going to be talking about today, as well as having links to a GitLab where you can download the current state of the repositories. Also, we have on that page links so that you can get the repo at each step. So if either you are falling behind or you have to jump in and jump out and want to pick back up right where we're starting, you can clone the repo or download the zip and start the project right where we're going to be for that step of the phase. So we're making it easy for you to follow along if maybe things aren't working out so well on your own side. So we have all those different steps and links there. So you can also just jump ahead or get the code where it needs to be for the discussion. So I recommend you go to that page as well, because there's also some links in there we're going to need regarding APIs we want to hit and just some general informations. So keep that one handy. I'll be posting it a number of times in the chat room. So today, though, our three experts, our three stars of the show. We have Daniel Olatoye, who's going to be doing our first talk, Satish Yadav doing our second talk, and Jerrell doing our third talk. All these fellows are great parts of our Android practice here, experts on what they do, and they are all just fantastic individuals, as I know, and I know you're all going to think the same thing as they lead you through this wonderful journey of KMM. With all that being said, I'd like to now hand it off to our first speaker of the day to give us our introduction to all things KMM. Daniel, take it over.
Right. Hi, everyone. I'm Daniel Olatoye. I'm an Android engineer at InRhythm, and I'll be running you through the introduction to KMM today. So I have my slides ready, and I'm going to present that right now. Okay, welcome to InRhythm Engineering Android Practice, KMM, Kotlin Multi-Platform Mobile. So this is one of the latest technologies out there in the world of mobile development. And KMM is an SDK designed to simplify the development of cross-platform mobile applications. And briefly, before we dive into KMM specifically, let's talk about the brief challenges of building mobile application. So in the world of mobile application development, things can be complex, things can be time consuming, especially if you're building your Android and iOS application separately. And each of these platforms, they have their own programming language, they have different APIs, they have different environments set up, how you interact with them. And this, especially when you are building an application that does a particular thing, and you have to build your Android and your iOS separately, this can cause a lot of duplicate work and requires a lot of specialized knowledge. But here, KMM breaks that divide and allows you to write specific codes which could be shared across these platforms. So in today's outline, we are going to be looking at introduction and what is Kotlin Multi-Platform Mobile. Under this, we have the brief overview of KMM. We have the comparison with other cross-platform development tools. We have the actual diving into the KMM architecture and how it works under the hood. Then we also have the impact of using KMM on development teams, what it can do, what it can solve, what benefit it brings to your development team, and should you use it? Then we also have best practices of using KMM, because this technology looks like it seems too good to be true. So there are best practices and guidelines on how to use KMM. Then we are going to be looking at just a brief setup for our KMM application. So yeah, moving on, we know KMM is developed by JetBrains. It allows you, so pretty much allows you to write shared code for both Android and iOS. That is where the concept of the cross-platform development comes in play. Then it is modern, it is expressive, it is concise, written in Kotlin, and you write code once and use it across multiple platforms. And the impact of this, it allows you to save time, reduce complexity, and easily maintain your code base. Then, as we know that we all like sharing code because we understand the value of reusing that code, we understand the value it brings because it provides consistent logic, reduces the number of bugs, and speeds up development process. But with KMM, we can see a representation of how it works because there is a shared code module which you write once, and you still have your native code, your native implementation intact. And this implementation sits on top of the shared code, which has your business logic and your core common module. And there are specific there are platform-specific APIs implementation in this shared code module, which is specific to the particular app you're building, whether your iOS or your Android APIs. You implement your native UI, your native code, and this directly sits on top of the module, which you share across both platforms. And in this example, I have iOS-specific APIs and Android-specific APIs, which you can see they directly use the native implementations of all of these APIs that you have. And yeah, you might say, Olop, isn't this cross-platform development? Well, cross-platform development often use a single code base and rely on native platform-specific implementations. And we have examples of cross-platforms that you might know, like Flutter, React Native, Ionic, Xamarin, Cordova, and Native Script. But yes, it is actually what you're thinking, because the answer is yes to some extent. KMM is cross-platform development. But where KMM really shines out is in its ability to write platform-specific code while you still maintain your shared code base. Even though KMM is not only the way to share a specific piece of code, many mobile teams, they have found a way around it before KMM came up to use JavaScript to achieve the same thing. But where KMM helps development team the most is as things become complex, the complexity increases, the logic increases, there is a negative effect to the performance of the application. And in the mobile development world, we take performance seriously, memory optimization seriously, and KMM allows us to achieve all of this flawlessly. KMM allows us to maintain the consistent logic while keeping the performance at a native level. But shared code written in Kotlin is compiled into JVM bytecode, which is Kotlin's JVM, and to native binaries with Kotlin native. That's why a lot of companies already migrate to using KMM while they are using JavaScript to share code between platforms. And I would like to talk about how that is done because it is very interesting. It is achieved by using by embedding a web JavaScript code into mobile applications, which allows you to exactly ship products faster. And but with this there's a trade-off in this, the trade-off of performance and Apple bundle size, because when things get more computationally and structurally complex, JavaScript cannot handle this, but KMM does this flawlessly. And you can take advantage of platform-specific features, optimizations, without having to write and maintain separate code bases for each platform. KMM allows you to write it once and implement it on different platforms. Now we have the KMM architecture and how it works. This is a very interesting architecture that KMM provides for us. And a high-level explanation of this is there is a common code which is shared across Android and iOS. And this will be compiled to respective Android and iOS applications. But what is more important is that there is also Android-specific parts and iOS-specific parts, which will be compiled only to Android and iOS apps, respectively. And the beauty of this common code idea is that KMM does not force you to share what you don't want to share in any particular platform. It only allows you to decide what you want to share. And on the Android side of things, the Kotlin code will be compiled to JVM bytecode, just like native Android does magic. And the JVM bytecode will be transformed into DEX. So DEX files are these files that contain code which are ultimately executable, and they are ultimately executed by the Android runtime. And you can upload this to your Play Store, or even still, you can share it internally for testing. But for the iOS side of things, the Kotlin native compiler will transform this Kotlin code into the so-called LLVM-IR, the intermediate representation, the LLVM intermediate representation. And this is the very same representation that Swift compiler uses. Then this LLVM-IR will be transformed into a native executable binary, which is the same tool chain that Swift application uses. So KMM basically uses the same representation as native app does. That is where you get the performance, the efficiency, and the running your application smoothly because it's a native platform. And that is just a brief rundown of this architecture that KMM provides for us. And the impact of using KMM on development teams. So KMM leverages on shared code base, which can be compiled to native code base. And the advantage of this is that you have greater code sharing capabilities than other frameworks, other cross-platform frameworks provides, and it results in faster development and reduce maintenance costs. Also, the value that KMM provides is a native performance, which we have been discussing, because it makes your application faster, more efficient, and it saves time and money for your company. Then you have direct access to native APIs. You don't have to use third-party libraries to access native implementations like your camera implementations, your push notifications, your Bluetooth. You communicate directly with your hardware natively. Then you have better integration with your platform, your Android or your iOS. Then overall, it increases productivity and communication amongst team members. Okay, the value that we get from KMM, what KMM offers, is when you are working with applications that require consuming API from the backend, you have an Android application to build, an iOS application to build, and you want to consume APIs from the backend, you don't need to write it. You save time by writing it once, put it in your shared module. KMM handles that in the shared module. Then you implement your backend API once, and each platform could implement what you have written in your shared module. Then also talking about the shared module is sharing the business logic, because this business logic lives in the shared module, and KMM allows you to implement it. And if you have particular implementations for different platforms in the shared module, KMM offers you the actual and expect keyword where you can use to implement particular functions for platform-specific implementations. Then you also keep your raw data models identical across platform. You don't need to be concerned about having something designed this way on Android and having the same thing designed in another way on your iOS. They are all identical and you get the same results. Then code ownership and testing uniquely and separately from platform teams and platform codes. Then you have very structured code base across platforms. Then optimized memory management, which is one of the key features that KMM offers. The memory management is way optimized across platforms. Okay, should my company use KMM or not? I would say yes, with all the benefits that KMM offers. You should consider looking into KMM because you have faster development times and easier maintenance, which can ultimately lead to saving time and money. And then developers, they collaborate better, which prevents miscommunication and mistake. Then developing one library for many applications. So for faster and more efficient times, since KMM compiles directly to native code, it can execute faster and more efficiently than code that runs on virtual machines or interpreters. This is especially noticeable in CPU-intensive tasks and when working with large amount of data. And better integration with the platform. When building an app natively, you have more control over what your app interacts, what platform it interacts. Then you can include things like accessing device-specific hardware, optimizing resource usage, or customizing the user interface to better match the platform's design guideline. By leveraging on the native performance of KMM, we can build applications that are tightly integrated with the platform and provide a better user experience because we want our users to have this native feel. We want the app to be fast, to be performant for them. Then developing one library for many applications. Sharing code is not the only way to work with KMM because it can be smooth. It can be smoothly integrated with native code base, and you can use it to develop a mobile SDK, just one library that can be integrated into many applications. I have seen this work in cases where we have a library, a KMM library, and you can develop applications from it. You don't need to write any code. You just use the functionalities that the library provides and build your own application from it. Then these libraries can be hosted. You can publish it to the Maven central repository, just like we have in the native Android ecosystem. Then you can also release it, publish it to CocoaPod or Swift Package Manager. And this is courtesy to the XC framework generator. Okay, so a tidbit of how KMM impacted my work in past teams. Just like I said, we have the library, the KMM library, which saves time, which saves a lot of effort. And we pretty much just extend this library, this module, to other applications where we have it compiled already and use it in other applications. Collaboration was top-notch using this KMM library. Then little code was written in developing the particular Android application. Then I could also interact with the iOS developers freely because we had a common module to use and we had to collaborate on that. So it was a great and exciting project to work on. And that is my experience, one of my many experiences using KMM in my past teams. So the best practices for using Kotlin Multi-Platform Mobile. So just like I said, when using KMM, which might seem too good to be true, there are several best practices to follow to ensure that your code is organized, maintainable, and efficient. And these are organizing your code structures, managing platform-specific code, sharing code across multiple platforms, integrating with third-party libraries, and optimize performance optimization. So to make your code base manageable, it is very essential that you organize your code properly. And a good approach is to separate the shared code from the platform-specific code. The shared code will contain the business logic and the UI components that are used across different platforms. And one way to organize your code structure is by using the common main source set. This contains the shared code and the platform-specific source set, such as your Android main, your iOS main, which contains the platform-specific code that you are using. Then you can also create subdirectories within each source set to further organize your code. Then in managing platform-specific code, KMM allows you to write platform-specific code that can be used in a specific platform to manage the code which you are using. And you can use this with your expect, just like I highlighted earlier, your expect and actual keyword. Then your expect keyword is used to share code and declare an API that should be implemented by each platform-specific code. Then the actual keyword is used in the platform-specific code to provide the actual implementation of the API. For example, you can declare an accept function in the shared code that performs a network request. We all call APIs at some point in our Android iOS applications. Then the expect function would handle this for you. Then when you want to implement that function in particular, you can call the actual keyword. And this way you write platform-specific code without compromising the shared code. Then sharing code across multiple platforms. One of the benefits that KMM offers is the ability to share code across multiple platforms. And to achieve this, you need to ensure that there is a shared code and your shared code is platform independent and does not rely on any platform-specific API or libraries. You can just use the expect and actual keywords, which are powerful keywords, to define the specific implementations for the APIs on this platform. Then another way to share code is by creating common libraries, which can be used by multiple projects. These common libraries can contain common UI components, networking code, or utility functions that can be used in different various projects. And you can publish these common libraries to a repository or use them in different projects. Then when you are integrating with third-party library, KMM supports the use of third-party libraries, but not all libraries are compatible with KMM. To use a library in KMM, it must be written in Kotlin or have a Kotlin API. And this way, using a third-party library, you can ensure it is compatible with the platforms you are targeting. And you also have to check whether the library has a platform-specific dependency or feature that may be available for other platforms. And KMM pretty much handles everything going on there. Then to ensure the performance optimization, KMM applications run smoothly. You just need to optimize it just optimize its performance. And one way to do that is by also using the expect and actual to ensure that platform-specific code is executed only on relevant platforms. You don't want to have irrelevant implementations in your platform-specific APIs. That is why KMM allows you to share what you only want to share, and it doesn't force you to share what you don't want to share, what a platform does not need, iOS does not need, or Android does not need. So another way to optimize performance is by minimizing the amount of data that is sent between the shared code and the platform-specific code. And you can use Kotlin data class serialization library to ensure that data is sent in a platform-independent format. So we would move on to looking at how to combine all of this knowledge together and build a KMM application. So the prerequisite to this is you should have a JDK, a Java development kit. You should have Android Studio or IntelliJ, and you want to also install your KMM plugin. Then if you're looking to do the iOS side of things for KMM, you should have Xcode and also have CocoaPod. So there are links to all of these, and yeah, you just have to have them set up on your machine and run a KMM application. So for this, there is a walkthrough, but we are going to be doing it together. But diving right in, we want to create a new. So I am doing this example using Android Studio. So on Android Studio, I have my KMM plugin set up. That is how I can see a Kotlin multi-platform application, which is selected. And when I click next, it's pretty much asks me to put in a name and the location for my KMM application. Then I choose to name my Android application in my shared module. And by default, it is named Android app and iOS app. Then the shared module name is shared. By default, it is named shared. Then I could choose my iOS framework distribution. There are two options to this: the regular framework and the CocoaPod dependency manager. And for this demo, we are not building anything too complex. So the regular framework works. It works just fine for it. So when I'm satisfied with all the namings or the settings, the setup for my KMM application, I then proceed to selecting the minimum SDK and the packaging for it. Then when it is all done, I can see my application overview. I have my Android app and I have my iOS app as well. Then I have the shared module where KMM really allows me to share platform-specific implementations and common implementations across these platforms, just like we see here, the common main. Then when that is all set up, I can start implementing platform-specific APIs onto the UI implementation and consuming APIs on different platforms. So I would like to actually do this live with my Android Studio. So if my Android Studio is visible, can anyone see my Android Studio? Okay, good. I will just need to hide this. Yes. And with that being said, I can do a demo for setting up a new KMM application. So to set up the KMM plugin, which allows you to select a KMM application at the point of creating your new application, you have to go to plugins. Then you have to go to, sorry, let me just take that one more. You go to your Android Studio options, then you go to settings, then you go to marketplace, then you search for KMM Kotlin Multi-Platform Mobile. Then you want to tap on this from your marketplace, then you install it. I already have mine installed, so I could confirm by going to the installed tab, then seeing that it is all set up. Then when I'm done, I click apply, then I click OK. Then I move on to Android Studio controls, where I can see my file. Then I select new because I'm creating a new KMM application. Then I select the new project, and I move on to searching for where a KMM application is. And I scroll all the way down, and I see my Kotlin Multi-Platform app. So you need to be careful at this point because there is Kotlin Multi-Platform app and Kotlin Multi-Platform library. We want to select the one that says Kotlin Multi-Platform app, which is this one. Then we hit next. Then we name our application. We set up the location we want to save it. Then we hit next. Then I'm fine with naming my Android application name and all of these settings. I'm fine with it, but there is just one thing, because this demo doesn't have so much complexity in implementation. We just want to select the regular framework. And yeah, when I'm satisfied with this, I also do not want to add tests for my shared module. And you just want to review this one more time and you hit finish. Okay, is my Android Studio still visible? Okay. Then I wait for Gradle to do its thing by configuring the project, because it's a new project and KMM is involved. We need to set up all the settings that KMM offers. Then when developing in Android Studio for KMM, we want to also see our common module, our shared module. And I don't want to set this to Android. So I put it to the project overview, and I can expand this and see all the options. So I can see my Android application. I can see the shared module where I would have what I want to share on my Android, what I want to share on my iOS. I can see it here, and I can start developing consuming APIs, network requests in my common main, and implementing it on the iOS. So for my Android side of things, implementing one we created as a new KMM application, and I was explaining how that developing for KMM, you don't want to have your project overview set up as Android only, because there's a shared module which you implement your Kotlin business logic in. So you want to toggle this over to the project overview so you could see all of this. And just like we had it in as a default naming, Android app, shared, then iOS app right here. So you would see everything set up for you by KMM, and you can start working with your shared module, putting your business logic in this part of your project, then consuming it on different platforms, which KMM provides. Thank you. Are there any questions before I hand it over to the next step?
Yeah, actually, we had a question come in from LinkedIn. We had a question from Rafat Nasirov, who was asking, do you think that KMM is usable for iOS applications in the UI sense, but using it to create UIs on iOS?
So KMM is only focused on sharing implementations, sharing business logic. So regarding UI, you would have to write your own UI for that platform. You are talking about iOS, so that will be UI kit or SwiftUI. Then implement your shared module, the functionalities from your shared module, but you would have to write. KMM does not write the UI for you. Your platform writes the UI. You write the UI for specific platforms. For Android, you use Jetpack Compose, but writing the UI in a KMM project for iOS, you use your SwiftUI or your UI kit.
Brian also has asked us a question in text or in the chat. He's asked, what outstanding advantage does KMM have over Flutter?
Over Flutter, I believe having direct communication with the APIs, the native APIs, is what KMM also protects as a native implementation of mobile applications. So I know Flutter, you need to install third-party libraries to access some native APIs, and this could pretty much hinder the performance of your application. It could as well bloat up the size of your application. So KMM provides a native implementation over Flutter, and you have your app size reduced, you have your performance top-notch, and your users have that native feel as well.
To summarize what you're saying, the value here is that you get to keep the native UI, you get to keep the native language on iOS and Android. You don't have to write some middle UI. It's just basically the core logic you don't have to repeat, and then you can do it specifically as native as you want in iOS and Android, correct?
Correct, yes.
Awesome. And the core KMM module can also be used on web as well, correct?
Yes, yes. Yes, it's gone.
Great. All right. Well, thank you so much, Daniel. We're now at the end of our first talk today, which is, the great moment where we're going to now go into our first code workshop. For everybody who's currently on the line, we're going to go into some breakout rooms, and hopefully everybody can get their environment set up to that hello world my application step that Daniel showed off. So we'll go into some breakout rooms here, and we can work with each other, have discussions about what's going on. And 30 minutes from now, we'll rejoin here for step 2, where Satish will take us through the next steps. So to cover that again, we're going to go breakout rooms, get the locals set up with our hello world. When we come back, we're actually going to start implementing APIs in our core module to be shared across all of our platforms, and Satish will be doing that. So now I'm going to ask Ted to help me set up the breakout rooms, and we can go all of our separate ways. And when the time is up, the breakout rooms will end. We'll give you a little notification. It'll bring everybody back here, and we can continue on with the next talk in 30 minutes. I see Rufat sent us in another question. I'm happy to answer that on Daniel's behalf. So Rufat, the popularity of KMM right now, it's growing a lot. Over the last kind of year and a half, it came out of beta and went into actual, production phase, kind of like a lot of recent Google technologies like Jetpack Compose and a couple other ones. So it's really starting to hit in a really good spot, as well as a lot of, the Android technology and the Kotlin journey that Google has been on for the last 3 to 4 years. I believe that it will be one of the most popular tools in the next coming year, because in my personal experience, a lot of the day-to-day development of a mobile developer is that we all have to synchronize with other developers. we have to spend time trying to work with our backend compatriots, and they'll give us, an endpoint to hit, a JSON contract. They'll give us a postman, and we are then forced to implement it uniquely on Android with retrofit and whatever patterns we have. We have to uniquely implement it on iOS using, either Combine or the new async patterns, and on web they have to do it however they do it. And even though we're all hitting the same endpoint, potentially our architectures are different. Potentially our structures of our code, or what we call our variables, are different. And so if we were able to share that core part of the business logic, where it's hitting the APIs, it's parsing the objects, it's giving you back the objects and doing any transformations that are needed, like in a clean architecture, that means that both platforms, they don't have to write that logic themselves. They can just use the library. They don't have to unit test it. They don't have to validate it. All they have to do is write their actual consuming UI to it, and they can continue to write their UI in the native platform that's, they're most comfortable with. One of the big problems with a lot of the other multi-platform technologies is that they attempt to make a one UI for multiple services. Something like React Native or Xamarin or Flutter. It tries to give as much of the same experience on Android as iOS. And for any designers, or for any people who really feel strongly about the design language on each platform, such as Material on Android or Flat UI on iOS, that sort of middle tier UI just does not feel correct to the end user. And it also doesn't feel, sometimes not as responsive. Like React Native can be a little less than responsive, depending on, hardware and depending on how it's coded. So by being able to completely maintain native UI in whatever language developers are familiar with and whatever is important for that platform, it means that you don't have that design schism. It means that you don't have that interaction problem. And then the core business logic is identical across platforms. So all consumers are talking the same language, using the same bit of code, and we don't have to write it ourselves. It saves time. We also don't have to potentially have individual bugs where maybe Android parsed the library a little different. Maybe they thought this was a string, but it really was an enum, and we didn't have all the enum cases on Android, but for some reason iOS got it right. That's like one of those per platform bugs we sometimes see that will be eliminated by sharing that core. And additionally, depending on who's able to be owning that core logic to be given to all the different platform teams, it can be tested and verified completely separate from any of the consumers, giving it a lot more flexibility in the long term when it comes to just an organization's stability on their endpoints. It can be used for more than endpoints too, just any shared logic or shared stuff, but the power is keeping the UI on the actual platform side in native platform code. I hope that answered your question, Rufat. Hey there, I see another question here. Rufat, my opinion about AI, do I think that it can handle projects? Honestly, I don't think so. AI is built off of example and sample data. If you had an AI write you a sample project from Android, it would probably look at Stack Overflow, would probably make you something that might work, but it'll probably be something from 2013 with a bunch of activities and XMLs. It probably would not be modern, wouldn't be Jetpack, it wouldn't even be Android X. I am not afraid of the AI revolution when it comes to code. Hey, looks like we have something to talk about here, Mike. Have I explored using KMM for background upload or download? I have not personally, but it sounds like an actual wonderful use case. Considering background tasks in Android and iOS are so wildly different when it comes to whether or not the operating system is going to cancel your background tasks, regarding whether it's kind of a local broadcast or if it's a background service type thing. It seems like a great use of keeping a long-running service consistently. But I would imagine that there are some complexities regarding the expect actual, just to make sure that you're playing nice by the operating system. But as long as the app is open and foregrounded, I think it's a great way to just shuffle off some heavy data to a completely different part of the application, such like maybe doing image manipulations or uploading video streams, stuff like that. In my perspective, the real value of putting any shared logic into a core module is such that you don't have to write it twice, such that you don't have to encounter the same speed bumps and remake the wheel depending on whether or not your, the device in your hand is Android, iOS, or web. Not having to reinvent the wheel is the most important part here, while also being able to keep, the experiences as native as possible and consistent with what your user expects, like from their iOS apps, from their Android apps, and to not make some middle ground thing that isn't material or isn't flat or, whatever else. So that is a great use case, I think, of where KMM could be fantastic. So now we'll be moving into the second phase here of our meeting today. So hopefully everybody was able to get their local environment up to the Hello World spec. Everybody's in a really solid base level so that we have our core module set up. We have our empty iOS app, empty Android app, and we also have our common Android, common iOS setup with our little Hello World greeting object that Android Studio creates for us by default. So the next thing we're going to do is actually write code, for realsies. And to do that, Satish Yadav, senior Android engineer here, is going to be leading us off. There are two endpoints that we're going to be connecting and using. They're fake endpoints, but we have them up on our Summit page, summit.inrhythm.com/Android. We have both those APIs available on that page to click. They're unauthenticated. They're just some raw JSON, and those will be the things that we are going to be using and Satish will be talking about. But with that being said, Satish, you want to walk us through actually getting to business?
Yeah, so this session is mostly going to focus on how to make API calls using KMM. Keep it in a shared module so that it can be consumed by both iOS and Android app without having to write it twice. So to start making those API calls, the first step is basically adding the dependencies we need for that. And we use this library called Ktor. It's a networking library, which is purely written in Kotlin, and it will work for us. So these are the dependencies we'll add shortly in different modules. Why do we need them, and all that I'll explain. Then after we add the networking libraries, we add dependencies for coroutines. So once we get the response back from the API, we need it's async response, right? So we need to handle it in async way. So we'll need the coroutines, and for serialization of the JSON data, or because the API is returning us JSON data, we need the serialization libraries as well to basically pass it to the objects. And then we will go through what there are some permissions needed for us in order to make network API calls on Android. We are just focusing mainly on Android here. And this is the actual code we will be writing. Like we'll write our data models, the API handling code, the repositories, and the dispatchers, which will actually dispatch the response to the native apps. So let's get started with Ktor on my Android Studio. So what do you need to start with? You need to go to shared module first and open the Gradle file from the shared module, which is this file over here. And you'll see that we have different source sets. We have common main. So all the libraries which are dependent, common main is dependent on will go inside common main. The libraries which are consumed by Android main will go in Android main, and same for iOS main. So start with, let's add dependency for common main. So first dependency is adding the core Ktor module, which is this. And before that, I had to specifically add the version as well, what version I'm going to use. So let's define a version. So we are using this version for now. This is the main core library we need for common main, and then for Android main. We add this library. So this is OKHTTP library, which Ktor uses under the hood as an engine to drive the network calls. We need similar library for iOS as well. And iOS uses Darwin. So iOS main will have a Darwin. So these are all the network libraries we want to add in here. Next is the coroutines. So we have JetBrains coroutine library we'll add in common main first. And I'll explain how we are going to use them later. And then that's all we need over in the common module. I'll explain, like in Android app also we need to add coroutines, but maybe I think Jay might cover that once we have a UI implementation done over there. So for serialization, we have two libraries over here for common main. One is Kotlin Compose serialization, and then another from Ktor is negotiation one. Yeah, so the serialization is basically I'm using a JSON serializer here because my data is in JSON, and content negotiation is basically used to define what kind of data you are dealing with. Either it's content is XML or JSON or whatever. So it does a negotiation part when it's passing the data. So you need this library as well. And let's add plugin for serialization. So you need to go to project level Gradle file, which is this, and add this plugin for serialization. And then in shared module, again, I'll go back to shared Gradle file and add this plugin over here. Yeah, that's all. I think that's all we have to do for the library dependencies. And then once you add all of them, just click on sync now. So while that is syncing, let's go ahead and finish the rest of the code as well. So go back to your Android app and open manifest file and add this permission. So you need this internet permission basically to make any network calls. And this is only for Android app. You don't need that for iOS. Yeah, I think the libraries are working fine. Yeah. So we have finished adding the dependencies, permissions. Let's go back to the coding part now. So we'll first finish whatever we can cover in the common module. So mostly our API calls, defining the data models, writing repositories, all will go in the common main. So let's create packages for them, each of them. I'll start with a model. Then I need a API package as well. I need a repository. So in my model, right, I need to have an exact model what my JSON is going to return back. So let's see how that JSON looks like. So this is the first API we are going to call. Let's make it look prettier. Yeah. So this is how our first API call looks like. So it has an article list, and each article has these properties or fields. It has an ID, title, description, URL for the article, thumbnail for to show it in the list, when was the article published on, the author of that article, and how you want to present it, whether it's a full or compact in a view model. So inside my view model, I need 4 models basically. I need an article model. So I go in my model and say new Kotlin class. It will be a data class, and we'll call it as article. Let's write the contents later. I'll first create those classes first. I need an article list. Which is again a data class. I need an author class, which is also a data class. So everything in the model is a data class. And I'll have an author list. So what goes in my article class? I'll just copy paste right now because it will take time to type everything. If you look at our JSON, right? So it has those fields. So it's same our data model represents over here. But if you observe that I don't have this serialized name annotation for all of the fields, the reason for that is because the name, ID, title is exactly matching what I have in the JSON. But for the fields, like for example, description, in the description, I can choose to have a different variable name, but then I'll have to specify the name I'm using in the JSON. So that's where the serialization library helps us to do that, and it will serialize my object completely. For example, all where I'm using serialized name, it has a different variable name, and it also supports enums. So I have created an enum class here for compact and full, which was represented here in our in the JSON. So that's it for the model class. I created my model for article. Now I have to create an article list model. So it is nothing but it's a list of an article object over here. So let me copy that code as well. Yeah, so it's basically a article list with a type of list, and it's holding the article object over here. And quickly, let's finish the author of it. For author, we have a separate endpoint. I can show you how it looks. Let's finish this first. Right. So here is the author endpoint. It's a different endpoint we marked. It basically has the first name, last name, and the ID, which we will map to the article list again, and pull the profile image for that author. So that's all we need for the model. All our models are created. And now next thing is we create an API class. So what this API class is going to do is actually going to use the Ktor library to make the API calls. So what we start with creating that class for us. So it's a normal class. Which says articles API. I'm going to import all the necessary libraries we need for this, and then I'll explain why do we need this. This will be spread about this for now. Yeah, so I first define all my API endpoints, which are, we have two in this case. So I create a variables for them. So these are my two endpoints. And then I'll basically initialize my Ktor client in a variable. So if you see that it's basically has an HTTP client class inside Ktor library. And it basically is using that content negotiation we spoke about. And in my case, I'm using JSON. If your API is sending back XML or some other kind of data, you can change that content negotiation over here. Pretty print is for if I want to print that JSON, it will basically print in a nice format for me. Even if the API is giving me like a compact format or something like that, but it will print me in a good hierarchical fashion. Ease lenient is something we can use as true if you want that from minor, if the JSON is not formed correctly or malformed. Like for example, for a Boolean value, I'm using into quotes true or false instead of just true and false. It will ignore that and will parse me for it. So if I say is lenient is equal to 2, it will ignore those minor errors for me. And then my API class will look like this, which I'll explain shortly. So basically, it takes an HTTP client, which you already defined here, of the Ktor client, and I need to import article list, which is our model which we wrote. Author list. So this is basically just we have written two methods, functions, get articles and get authors. It's making an API call on this client, the Ktor client. We are passing that API endpoint, and the body will return me that response back. That's all we need for the API class. The next one is the repository class. I'll call it as articles repository. Then I'll import all the libraries I need there. So my articles repository is going to have a constructor which takes in the articles API, which we already wrote just now. And again, you can also use dependency injections for these things, but just to keep it simple, I'm just initializing that API over here in my constructor. Then I have a method called as fetch articles. We'll talk about application dispatcher later, but for now, let it be like that. So what this is doing is basically it is using coroutine called flow. So we have multiple options with coroutines. Flow is one of them. So flow lets us basically emit the response as is it's processing the response back to its collector. So flow is better in many ways. You can also use other coroutines like async await and all those things, but I choose to use the flow here. So it is going to emit me the response back wherever I'm consuming it, collecting it basically. And flow on is basically what thread you want to push this response on. So I'll explain that shortly why I'm using an application dispatcher here. But before that, let's write a method for authors as well. So this is the author. Yeah. So that's all code we need for repository as well. So till now we finished code for models, the APIs, and the repository. Now, what is dispatcher? So dispatcher is something very native, native to iOS and Android. What way we want to basically transfer this data on what thread we want to transfer. So iOS has its own way and Android has its own way. So what we are going to do is write an application dispatcher class in common main. Let's call it as an application dispatcher. And I'm going to import coroutine I need for this, for the dispatcher. And so in this class, we are just, it's just a Kotlin file, and we are just going to define a variable we want to use. So if you see here, I want the coroutine context from each native platform. So I'm expecting implementation for that from both the platforms, which I should be doing it in my submodules, Android main as well as iOS main. Once you use expect keyword from KMM, it expects an actual implementation. So here, if you mouse over here, it will say that there is no actual implementation for this. So we need to go and do that for each modules. Let's start with Android main. I can call it whatever I want. Let's say Android application dispatcher. Then that I'll have the actual implementation for the coroutine dispatcher. Yeah, the dependencies, and then again it will just define my variable I want to use. So I'm using a IO dispatcher over here. So we have different dispatchers which coroutine offers. It basically tells us what kind of thread it is going to use for this. So IO, it's IO because it's a network operation. So we are using IO, but we also have main, in which case it dispatches on the main thread. We also have default and multiple options for here to use. In this case, we are using IO dispatcher. So I have implemented the Android actual function or actual variable for this, which I'm going to use. And then I have it is going to still complain me because I'm still missing the iOS part I need to implement. So let's go in iOS and implement the same class over there. And I'll call it that iOS application dispatcher. And I'm not too familiar with the iOS part of code, but like how the coroutine, it supports coroutine, but not to its full extent. So it has its own mechanism, like using the dispatch queue from the Darwin. Let me write the code over here. So this is what the application dispatcher for iOS looks like. Now I go back to my application dispatcher in common main, and you see that the error is gone now because I have actual implementation for both iOS and Android. Now this is still complaining because I haven't imported that here. So I'll just go and import. That's all. And that's all code we need to write for the shared module to work. And then the next part is implementing UI, of course, and I think Jay will do that mostly, but I can show you how it works. I have already done some basic UI stuff using the same stuff we did just now, which I was copying from. And let's run it. So you'll see that it's basically, I'm just printing the JSON, which I'm getting back from shared module. So it's basically printing the same JSON of what we are requesting it from the APIs. But to make it look nicer, I think Jay will cover that in his next session.
Fantastic stuff here, Satish. So I guess to summarize, what we've looked over now is we have two kind of fake APIs, an article API and a user API, and we showed how to implement the core logic to pull it from network, parse the data models, and give it to both the Android and iOS side, as well as some unique differences about how we want to be handling that in iOS versus Android for particular primitive types. So that's awesome. That's the primary use case of KMM. And I think you're totally right that our third talk today will be Jay actually consuming this on an Android application. But thank you so much for showing us that it does work here. So I think this is now where we're going to slide into our second coding breakout rooms, where we will try to implement to this API. So using our Hello World application that we created, we're going to try to replicate what Satish has shown here, creating our data models and our API layers and our injections with expect actual. We're going to try to get to that spot as well, get all the way through it, so that when we do come back, Jay will be able to start with a working solid core module and be able to then start writing some Android stuff and show some iOS stuff. So that being said, we also have the code repositories, both in GitLab publicly and in zip demo form on our Summit webpage. So if you're falling behind or just want to kind of speed up a little bit, you can download those from the website and get a leg up on where we're going. But once we are done with our next 30-minute session, we're going to have a little bit of a coffee break. So it'll probably be about 45 minutes before we meet again, at which point Jay will be leading us into the actual platform usage of this core module. All right, welcome back, everybody. So I hope that everybody was able to get done what they needed on step 2 to implement to our wonderful fake API. Now in our schedule, we have a 15-minute coffee break, because I'm sure if everybody's been diligently working and stretching out in those rooms, might be time to get up and stretch the legs. Before we do, though, I know that the next talk, Jay Jerrell is going to be having us implement our core into the platform. And I think that Jay wants to tell us a little bit of maybe something to prepare in our 15-minute break here, correct?
Yeah, so a little bit of boilerplate was done between step 2 and step 3, just to move things along a little bit. So it might be best to either download the zip, upload it to our page there that Greg's showing, or to simply reset your local changes and then do a git checkout step 3. Once we come back from our coffee break, I'll give us a walkthrough of the boilerplate that I laid out. We'll do a little bit of hands-on stuff like Satish did, and do some demonstrations of what took place for both Android and iOS.
Awesome. All right. So this is just to help people along. If you feel very comfortable doing a bunch of Gradle setup and doing a bunch of general Compose navigation, you can go for it. But we figured that most people here probably know how to do that, or that's not the focus. So we wanted to give you the jump start into the just working with the KMM part in Android instead of, everything in Android. So we have a source code zip there. We also have the GitLab, and hopefully when we come back from our coffee break, Jay will start us off right there with that step. All right, so I'll throw back on the lo-fi, and we will see you guys in 15. So we are about to head into our third and final talk for the day. Well, let me get Dan admitted here. Right on. So we're about to go into our third and final talk of the day. Our first talk obviously was setting up KMM. Our second talk was implementing an API. And now, to bring it full circle, we're going to actually be looking at how to use a KMM module, mostly on Android, but also we're going to look a little bit about using it on iOS to actually show the power of KMM and sharing this code. And to do that, we have Mr. Jerrell here, one of our most senior Android engineers at InRhythm, to lead us through and take us home. Jay?
All right. Thank you, Greg. Let me share my screen real quick and get myself organized. Before we went out to our breakout rooms, we asked if everyone could check out step 3 or download the zip, just to kind of get us up to speed a little bit. And I'll go over and cover some of the stuff that I did to get us from step 2 to where we'll begin this one. So let's see. Hopefully everyone can see my Android Studio now. So first off, when I started looking at iOS, so I'm getting ahead of myself a little bit here, had some issues with dependencies and versions and that sort of thing. So I'll just go ahead and open our dependencies class, which was made in build source, which was a fairly common practice if you don't use them, like the PUML file through Gradle. So we have our versions object. I have added the Compose BOM, the bill of materials, to sort of simplify that. So I was able to take the versions out of several of these. I also updated the Min SDK to 24 to get rid of some issues. It still supports like 98.2% of devices, so practically everyone. I had to make some changes to update the Kotlin compiler extension to 1.4.4, and I also added coils so we could load some images. So that's how we've ended up with the file in the state that it's currently in if you're on step 3. And I guess I'll start off by showing the changes that we made in Kotlin Multi-Platform Mobile. Let's see. So once again, getting ahead of myself a little bit because I'm worrying about iOS. But when I started working with the repository on the iOS side of things, started running into problems with the way that they had bridged flow. So what I did is I simply came in to the application dispatcher where we established the expect val. I created a class, common flow. I'll add a line break here so it's a little easier to decipher. But basically all this does is conform to flow by taking in the parameter here of a flow. So very simple conformance. You give it a flow, it's now a flow. Created a watch function, which uses callbacks. So it has a callback block for success or error handler, and it does return a closable so that it can be canceled. We'll go into a little bit more detail of that once I show the iOS part. Let's see. So that covers common flow and how we worked around one of those issues. There are some links on our Summit page, which gives a more complete example of a very similar approach. So if you were going to use this in practice, you might want to do something a little bit more elaborate than this. So at any rate, I did add a couple of extensions just to kind of showcase a little bit more about what KMM can do. Quite simple for this one on articles. I created a extension variable called open in browser. So if the article comes across with a URL and the presentation is deserialized as compact, it will not load it natively in the application. It will try to launch the device's web browser. Similarly, in author, I created a full name and put it together. That way I didn't have to concatenate in the UI logic. It was just done in one place, so both iOS and Android have access to it. And let's see. So I guess moving on to UI updates, as I mentioned, I did do a bit of boilerplate to get navigation and that sort of thing running. And let's expand these things out. So I cleaned up main activity, just sort of moved everything out, like the theme I put over into the Propel KMM demo theme file, so it was separated. I propagated all of our experimental things up to the main activity. So everything else can just say, hey, this is using experimental, but the top level is what's actually opting into it. So it's easy to see which experimental things we're using. Yeah, So I think the shapes and type and everything was defined there already. So looking at main, which is instantiated by main activity, because with Compose, you still need at least one activity. It has a modifier, which gets passed in. It's useful for testing purposes, or you're reusing it somewhere you didn't plan to reuse it. You have some sort of control over it still. It accepts a view model. So for testing, you could pass in your own copy of it. Otherwise, it instantiates it through the standard view model delegation. And we've created a nav host controller, again, passing it in parameterized for testing, as you have a test nav host controller on that end of things. So anyway, once we got down to that, created a scaffold. We of course have to pass in the padding values to something so that it can conform to the device's constraints. So we did that here to get rid of any compiler complaints. Passed in the nav controller, our start destination, and then this is where we've defined our composables. So we've an article list now. It accepts a list of articles, which is just coming straight from the view model we passed here. In real life, it would probably be a little bit different. For the sake of simplicity, it's all just right here for us. So we pass it the list of articles or empty. There's the onSelect method, so that once the user taps on an article, if that open in browser variable shows up as true, it just uses the local URI handler to ask the operating system to load it in the browser. Otherwise, it does view model select article, which we'll look at the view model in a second, and then it navigates to articles detail. Articles detail collects the selected article and then the selected author, which once we look at the view model, we'll understand that part a little bit more. And it starts out as null, of course, just in case there's nothing there. The API call hasn't been made yet. And then similarly, we pass through the article and the author, not a list. We have the open URL, which basically just calls back to the URI handler that we instantiated in here. And we have select author, which says to navigate to the author detail page, which again, just basically gets the selected author from the view model and then creates an author profile. It also updates the title. That way the nav bar from the scaffold is sort of reactive. It'll change from InRhythm to the name of the article or author you're looking at. Let's make sure that I'm on track with myself. Yep, I think so. All right, so let's see, as promised, let's look at the view model. So we know that it takes in the repository, which we created in main activity. Just we could have used dependency injection, but kept it simple for the purposes of this. We have our articles variable and then authors as currently private. And then we have selected article and selected author publicly exposed. Selected author is determined just by looking at whichever article is selected. So in that callback, once we set this value, it does a map latest, figures out what the author's ID is, and then it checks our authors list to see if it can find a match. Otherwise, it'll return null. Our initializer just calls load articles. So the moment we create the view model, we instantly make that network call to populate this value. And then this is the method, of course, to select the article. Once the user taps on something, that's what we hit, and it updates it, and then the map for authors takes place. And let's see, load articles had already existed from step 2, so there's no real changes there. Something interesting Brian and I were discussing in our breakout room, being that this is a list, if this were a more complex application and one of these articles was mutated, Compose wouldn't figure that out. So what we were discussing in our breakout room is using mutable state list of, and then getting rid of this and that. And we can even instantiate it empty and give it a second for it to figure out that it needs to do an import. There we go. I just practiced this. Okay, there it is. All right, so and there will be another error since we're using the state list. We'll have to change dot value to dot add all. And just to be safe, we'll go ahead and before we do that, we'll call articles.clear. That way we know we've got the fresh list. We're not duplicating it if a second network call gets fired for some reason. So just a couple of quick updates in there. This mostly originated from our discussion through Brian's questions while we were talking in the breakout room. And let's see, I guess, what better time to run the application and take a look at it. I did do some UI beautification and stuff. So we have like a list of cards that has a background image and a quick little snippet and some other UI niceties. So I did build before this, hoping that this wouldn't take too terribly long. It's also worth mentioning that I did add some theming. So I took InRhythm's colors and put them into the material theme pattern. All right, so one other change needed to be made since we updated the view model to use mutable state list of. We just basically had to take out the dot value, and then that makes dot or empty kind of superfluous because it automatically creates an empty list if nothing's passed to it. So we resolve that build error. And you see it does the compiling of the shared module, Android application. And since it's fairly simple, there's no other Android modules to be compiled at this time. So that's completed. We'll go ahead and run it over here. Of course, going to check a few things in case in those 2 seconds I managed to change something on it. And it launches the application. So we have our title InRhythm in the top app bar, and then our list of articles with a little background image being loaded through Coil. And to kind of show that, we can take a look at articles list, see how it's implemented. So lazy column using items indexed, taking the list of articles we pass through the parameter, and then it creates a card for each one, which calls on select for that particular article if it gets clicked on. And then our logic was written in main to figure out if it's going to go to the actual detail view or if it's going to launch in browser. I also added an icon to indicate that, hey, this is an article which will launch in your browser instead of locally, just to kind of give you a heads up so you're not alarmed after you've read the first one. And let's see if there's anything else. Yeah, I mean, the coil loading here, it's pretty basic using async image. I added a little bit of transparency so that it was easy to read the text in front of it. Probably could use a little bit of work for accessibility, but for the purposes of this, it's at least mostly legible. So we pass in the data, the article thumbnail, it's just the URL that Satish showed us. And then the size.original, it just makes Coil happy, basically. But then in here, we can tell content scale to crop it down to the actual size that's being used. So that takes care of that. There is something that I wanted to show, which Satish had set up, and I hadn't given it much thought until I saw it, and I really liked it. So let's see, where was that defined? That's important. You know what? If you do Command O or Command Shift O, even better yet, you can type in the symbol you're looking for, and it takes the guesswork out of going through all of those folders. So this isn't the actual implementation, but the expect is basically just a simple class called datetime. It's defined as being serializable. And then it has one function called getFormatedDate that expects an ISO 8601 timestamp, which is obviously the best way to express dates. And then it accepts a format string. and then it will output a date, assuming that you've given it the correct value formats. So on the Android side, getting the formatted date is fairly simple for version codes greater than or equal to Oreo, I believe. So you just call datetime formatter of pattern format, and that's about all there is to it. And then you return, of course, the date formatter. The iOS side of things, which is what I was most excited, I guess, to show off, because it shows how you can import modules and stuff from like Foundation and actually use stuff that comes from Apple within KMM, within Kotlin programming language. So sorry, we'll go to utils, datetime, and I'm gonna go ahead and show the imports instead of letting them collapse. We have 4 imports from platform.foundation. So we have an NS date formatter, NS ISO 8601 date formatter, NS time zone, and system time zone. Does a lot of the same stuff as the Android method. We've implemented our actual get formatted date, which accepts the date string, timestamp, and then if it comes across as a valid date, or NS date, I should say, then it actually runs through the date formatter and will eventually return a string. And if it comes out as invalid, it will just give us dashes. So I thought that was really cool. One way we can use that just real quickly, if we wanted to, is go to articles list. And then down here, let's see, we have a column and then a row. And let's see, that's our column scope. Yep. So if we just made a new line, we can go text. Text equals, what was it called at the time? There it goes. Yep. Wait for that import. So we'll do get formatted date. We know the ISO 8601. Oops. Wait for autocomplete and try to determine if I should have just typed it instead. And let's see, publish date is our ISO 8601 timestamp based on what we've seen from the API responses. As for the format, we'd probably use a constant in practice, but for here, we'll just do UD, YYY. And then if we save that quickly, we can see Android will look into its shared module. Not super impressive. A lot of us have used modules in Android, but at any rate, it shows how the actual unexpect behavior behaves. But what this will give us here is basically in that list that was shown, we'll now have a month, date, year formatted date down at the bottom, unless of course it's been overflowed by the preview text, because I did do strict height control on there, which again, probably something we wouldn't do in practice, but didn't want anything getting way out of hand. So yeah, as promised, it says 02/21/2023 is the date this article was released. So let's go ahead and take a look at that. So our details page, it does update the tab bar, gives us a back button as expected, and then it prints out the overview, which is just a brief snippet that was taken from the real article. If you want to read more, there's a button which launches the web browser so that you can actually see the true article on our page. So let's see, going back to our application, there's this little silhouette of an author. The silhouette of man. And then once you click on it, it takes you to this nondescript page. So we already wrote out in the view model methods for figuring out which author it is. We've got the variable there. We've defined the models and all of that stuff, but we've not given the view model any reason to actually fetch the authors. As we know from previous presentations, there are 2 endpoints. So what I'll do is just kind of quickly copy this function because it's going to look almost exactly the same. rename it because clashes are bad. Change that to authors. Yes, with an S. All right. And then, of course, we'll need to change this as well. And going back to what Brian and I were discussing, this could also be updated to mutable state list of. We can take out some of this. And it has to be the 5th and 6th time I've made that symbol on accident today. So yeah, we can also take out the value and the null check on that, but this still will be a first or null because it's quite possible that an author doesn't exist within the response that we got. Let's see. So for state management, we're using very simple values of error, which is a throwable, currently null, and is loading, which is a mutable state of a Boolean, which starts out as false. So the load articles sets it to true when it's completed, back to false. If it fails, we set the error value, and then we've already been over the articles. So let's see. So down here, we'll need to do a lot of the same things. Clear out the authors list and then add all of the authors. Okay, so since we're using the simple state management that we have, if I were to come up here and put load authors and then initializer, that'd probably be fine. But weird things would happen. It might like flash or something if we were to add some sort of indication for whether it's loading. It could feel a little bit glitchy. So what I've done is instead, I'll come in here and I'll actually call it in the onCompletion event, and we'll see where that takes us. That way it loads the articles. When it's finished, then it will go out and get the authors. That way they're both in control of their own state. Again, in practice, we'd probably come down here and do a sealed class or interface and, follow that common pattern. But at any rate, we are loading articles. We know that once that happens, we're going to call that method to load the authors, and hopefully our map latest and everything should work. We should see an image and details about the author. So with those changes, someone stop me if I'm moving too fast, but I'm gonna go ahead and run the application. All right. So nothing changed here, as expected. But once we come in, I apparently wrote this one. I do not remember that. I did put a disclaimer here. I'll shrink the debugging stuff. Authors are for demonstration purposes only. I did not write this one. So once we click on the author, we get some details. We get some nice lorem ipsum about the author. And then, of course, we still have our navigation so that we can go back. Again, another article, which Satish may or may not have written. And then somewhere down here, that one didn't have an image. There it is. Yeah, so this was the example where our map latest uses a first or null because for whatever reason, this particular article does not match an author that's within our API definition. So we need to make some updates to the API response to figure out who wrote this article and display that appropriately. For now, it's just giving us the placeholder that we had before. And let's see. Yeah, okay. So yeah, going back into the nondescript author at that point, since we know that this selected article in the view model over here can be nullable, as a practice, you could update the clickable modifier to just basically include the enabled parameter and set it to false if author is null or selected author is null. try to show that. Let's see. Profile. Sorry, it's only been a week or two since I did this. So here's our unclick. And here's finally where we define our clickable. So to edit that modifier, you just put parentheses there, and then you can do enabled equals author does not equal, author does not equal null. And then that would prevent us from clicking into that nondescript author and getting a blank page, and your users are wondering why you even bothered. So yeah, that would take care of that edge case. So something to talk through and think about. Let's see, as far as Android goes, I think that pretty well covers the changes that were made. I said I did the UI and all that stuff because this is really about KMM. So let's get to the exciting bit and look at iOS. So we know it's defined right in here, and we can access the code and everything. So here's the iOS app.swift file, which follows the new SwiftUI pattern. And then our content view, and I've created a view model. You can work with it directly in here. Autocomplete might be a little frustrating, and stuff like key paths, which Kotlin doesn't quite understand and Android Studio surely doesn't, might be a little bit difficult. So you can most certainly open the iOS app project with our next code. One thing that's important to note is that it's probably complaining. Let's see, once you load it, it will probably be giving a complaint about import shared or one of these other methods. It'll just be saying that it can't figure it out. That should go away if you hit Command B to build the application. And to explain why, we'll go into the iOS app target here, and then under build phases, open run script. And we see that it goes to the Xcode project source root, and then to the previous folder using the ... pattern. And then it just simply runs the local Gradle wrapper to embed and sign the Apple framework for Xcode. We will get a warning once we build this in Xcode that this will run every single time. In practice, we would probably release this either as a CocoaPod or as a Swift package, and that would reduce that. But as far as for development goes, demonstrations, quick iteration, and that sort of thing, this is simplest, because if I go over and make a change to the KMM project, the shared module, I know the next time I build an Xcode, I'm going to get that change rather than going and updating a version to the next number, for instance. So yeah, that is basically the default way to implement that, and fairly straightforward what it does. So for the content view, I spun up a navigation view. Swift guys, you've got it a little bit easier than we do as far as setting up navigation. I won't hold it against you. And within that navigation view, we created a list, which just looks at view model articles and then uses the article ID as the key path for maintaining uniqueness and position within the list and so on. I'm also making sure that the article URL is a valid URL string. And then if so, we create the link view, which is a native SwiftUI view. iOS developers are probably well aware of that. So we give it our article URL, and then we give it a label of the article's title. The navigation bar title is currently just articles, and then instead of using like an initializer, because they work a little bit differently in Swift, SwiftUI gives us this on appear. I don't even know what to call it, kind of like a modifier if you're an Android guy or gal. But so on a pair of this navigation view and or list, it will call viewModel.fetch articles. And that's where the common flow class that we looked at early on comes into play. So if we jump into that definition, we're just calling repository.fetch articles. We're using the empty constructor, which Satish had created. So we know that the repository is responsible for initializing the API. So Swift's not in any way concerned about its dependencies. And then the fetch articles method that gets called just simply hits repository fetch articles and calls the watch method, passed in the block, which receives an article list. And if it does come across as a list of articles per Swift annotation, then it sets this article's value to that list value. Currently, I'm just swallowing the error if one were to occur. Definitely probably not best practice. We do have selected article and selected author in here, but as we can recall from the content view, this is simply just opening a link within the URL. The more robust implementation would be more like what I showed on the Android side of things. But yeah, at any rate, let's take a look at this thing running in iOS. And then we'll jump back into Android Studio and kind of work through how you can actually run the iOS application directly through Android Studio if you wanted to. Let's let this finish its thing first. This is the warning I was talking about. I had it filtered out by using this button to show only errors, but it just simply says, like I described, the run script build phase will be run during each build. Let's see, we're still compiling. And we launch. So this will take a second. Probably didn't build the greatest UI UX experience, but it does come across with the articles once the list is instantiated, and then after a brief delay from the API, it gives us the list. And then, of course, as promised, it simply just launches Safari instead of going into a details view. But that is really all that comes down to it as far as consuming something within iOS is you import the shared module or whatever your framework may be named, and then you immediately get access to the models that come from there. Like article and author is not defined anywhere in here. And of course the repository, and it's super straightforward from my point of view. So yeah, going back to that, let's go ahead and stop this.
Sorry, Jacob, just wanted to add my 2 cents from the iOS standpoint. It's really cool stuff, how you can create this shared module so it can be reused across iOS and Android. Yeah, that's nice to see. And I've not been quite familiar with KMM before this workshop. Yeah, but this is definitely something to maybe use in the future. Yeah, good stuff. Thanks, guys.
Awesome. Yeah, glad you're getting something out of it. Yeah, I think it's super interesting. So yeah, as far as being an Android developer, if you wanted to test the changes in the iOS app, it is possible to just select from the run configurations the iOS app here. The first time you do that, it might come up with a dialogue, or it might just complain once you hit run. But it's just, you have to basically tell it what to run in. So if you select edit configurations, it takes you to this, and you can choose your execution target from all of the simulators that are available on your device. So I'll just leave it with the 14 Pro that we have running. Hit OK. And then here, let's actually debug it. And let's see if I can do this quick enough. racing the clock. Must have. So I'm basically just seeing if we will hit this breakpoint, and being that it's within the flow, maybe I ought to put it here just to be certain. Probably should have added a splash screen here so people know what's happening. Or wait. That's what's happening. We hit the breakpoint. So you can actually debug KMM code while running it through an iOS device, which I think is really, really neat. And it does come across with a different icon here to, I guess, kind of indicate that, hey, this is something else that we don't know too much about. So yeah, if I hit play on that, it's gonna hit it again. So let's mute breakpoints and jump back over here and actually get our list again. So Xcode is still a dependency. You need to have it installed, of course, and the simulator set up, but it in no way, shape, or form must be running as long as you have a simulator available. You can just simply launch it straight from Android Studio. That way, before you publish your changes or what have you, you can double check and make sure you're not going to make your iOS folks upset. I think that fairly well covers everything that I was going to go through here. We have consumed the KMM module on both Android and iOS. We set up an extra API call for the authors. We saw that get wired in on the Android side. Describe common flow, and then the date time shows how you use like foundation components and that sort of thing within Kotlin. So I guess I'll open it up if there's any questions from anybody. I've had the chat open here a little bit. I don't see anything coming across at the time.
Yeah, awesome stuff, Jay. Nick looks like Nikolai has a question.
Yeah, just quick question. I know maybe this has been covered already. How to set minimum deployment target for iOS and Android?
So in Android, we do it just in our build file. Let's see, is that top level? No, the one at the Android app, sorry. So that's just pulling from our versions object for the min and target SDK, and then file SDK up here, of course. As far as iOS goes, we've pretty much stuck with the defaults. Let's see, get my Xcode back up here. Yeah, and then, yeah, so iOS is just set with its deployment target currently at 14.1, just set through Xcode project settings, basically.
Okay. Yeah, and last question. In the Android Studio, you have a Swift file, right? And does it show a warning if certain UI component deprecated? Basically, does it show warnings in case of deprecations? Because this navigation view, it's been deprecated, and in iOS and navigation stack, it's like a replacement for navigation view starting iOS 16.
Oh, okay. No, I don't believe that it does show any sort of deprecation warnings from iOS or anything along those lines.
Okay.
It does give you like the build output and everything, but It doesn't look like they've incorporated the LLDB into Android Studio. That's a possible enhancement, but I won't speak for them on that. That does remind me of something though, the application dispatcher. When Satish was given his presentation, actually I kept the tab open here. Very common pattern. It's been around for about as long as I can recall. Like the first time I looked at KMM and had to deal with dispatchers and stuff like that across the board is this pattern here, which Satish showed. In some more recent versions, they give us a dispatchers.default. Now, last I knew, KMM was only supported with threading with the main thread. So default is available for the common source set, and it's perfectly fine to use it. In fact, that's what we've been using since I started presenting. An applications dispatcher, I'm simply calling dispatchers.default instead of using the NSQ dispatcher. And then, of course, we saw that within the Lambda or closure on the Swift side, I did use dispatchers queue.main. Yeah, that's something I was doing on my research. I knew an SQ dispatcher existed. I remembered using it. It was like on the tip of my tongue, and I could not find it for the life of me. But doing a bit of search, I found this was supported in the more recent versions. So I went ahead and used that instead. There's lots of conversations out there. If you do a search for it, you'll find loads and loads of information regarding multi-platform and iOS threading. And someone calls out that in literally all the examples this person found, they're using an SQ dispatcher like that. Yeah, at any rate, so we still have a little bit of evolution. It did recently come out of alpha, so we are in beta. Before it left alpha, big companies like Netflix and such had already begun using it. So I expect now that we're in beta, we'll see even more adoption. And then as we approach an actual 1. Release, I think that the possibilities are almost endless. You can write server-side applications, REST APIs, and all sorts of fun stuff through it. Sorry, I went on a tangent. Were there any other questions?
I think to highlight one more thing about that, Jay, is, traditionally, Nikolai, if you were doing your iOS development, you have Xcode open, and Xcode would tell you if something was deprecated or not. In Jay's example, we have both Android Studio and Xcode open in case we needed to do any work to the core module. But in a more realistic enterprise scenario, the core module would be deployed up on Swift Package Manager or something like that, which Jay covered a little earlier. So it's probably not very common in a real larger organization that you would have to be modifying both at the same time.
Yeah, that makes complete sense. Yeah.
Cool. Okay, well, we do have one last block of time left to go into any breakout rooms if people want to try coding up any of the extra iOS or Android stuff. We only have about 15 minutes left for that part of the day. So I'll throw us over to our breakout room so we can continue any of the individual conversations here, and then see you all back here at 5 o'clock to have our conclusions and happy hour part. We do have all of our sample code up there on our Summit webpage. If you wanted to pull down and play with what we wrote today, it's all there. So you can go step by step, see how we integrated it all. Feel free to grab it. It's not going anywhere. Both the zips and the GitLabs will be open and available for, Heat Death Universe or something like that. So they'll be there. Now, I guess before we finally call it quits, I wanted to open it up for any additional questions. We've had a lot of questions coming in from the chat, and we've had some breakout rooms, but now that we're all together, I'd love to know how you guys felt about today's presentation and what you guys think about KMM.
Yeah, I think you had a really great presentation going on today, and I really enjoyed it. Thank you guys so much. And one thing I was kind of curious on, the I guess when you're doing the development for like I noticed some of the Cocoa Pods, like, okay, so that makes sense, I think, with Mac, but what about for folks who are doing Windows? Like, is there an equivalent to something like that?
Yeah, so Cocoa Pods, is a Apple technology. It's an Apple package manager, but Android development can be done pretty much the exact same way on Windows, Mac, Linux. Kotlin is, basically JVM language, so it works anywhere. And the package manager that we use, Gradle, is platform agnostic as well. In fact, many of the build servers for a lot of Android pipelines are actually Linux based. So on Windows, you can't do iOS development at all, period, thanks to Apple. But if you were just doing straight Android and straight KMM, it'd work just fine on Windows or on Linux.
Awesome, great.
Any thoughts from anyone else about KMM?
Just a quick question from me. Like how much Google puts into KMM, and do you see it's like a big thing for Google, or it's like one of the cool features which Google offers? So
I'll give a one-sentence answer, but I do think that maybe Satish and Jay can also give more. I don't think it's going anywhere. I think that Kotlin as a language is something that Google will not abandon, considering that they've changed the entire Android ecosystem to start using Kotlin over the last 4 to 5 years. So I don't think KMM is going anywhere at all. And I think that they have sidestepped one of the biggest issues to a lot of multi-platform technologies, which is the UI layer. A lot of, Apple has gone out of their way to make SwiftUI cool to the point where you don't want to use something like React Native. And Jetpack Compose is also awesome. And so by KMM not trying to actually do the UI layer as well and just trying to be the logic layer, I think it has a wide, great future. But Jay, Satish, what do you think?
Yeah, I believe, if I remember correctly, it's actually JetBrains that fired it up, but they are working in partnership with Google in the public repository. Yeah, I think it's going to be around for quite a long time. I think we're going to see it mature a lot. There's server-side capabilities that are quite impressive already. So I think a lot of Java folks that are writing backend stuff might eventually switch over to using Kotlin even.
yeah, cool.
Okay, so I have a question for you. So as someone who's written Java for about 9 or 10 years, something like that, if I wanted to adapt to pick up Kotlin, right, to start doing things, how difficult is that?
You said that you have a Java background, right?
Right, yeah, and I believe Kotlin's all based on Java, if I recall correctly, anyways, or
Yes.
on top of.
So it is also a JVM language, so it goes down to Java bytecode. But Kotlin as an adjustment from Java, it's not the easiest in the world, but it is pretty easy. The most important thing to know is that it is a functional language with high order functions, and that traditional polymorphic OOP principles kind of don't. They work, they can work, but they don't translate as well with trying to do it in the Kotlin fashion. So you'll have to break yourself from a lot of abstract parentage, basically. But actually, Daniel, what do you think about that?
Yeah, I mean, with Java background, you could easily pick it up and start working with it. It's pretty much straightforward. I think it's the idea behind it that matters.
Satish, did you have the Java background as well?
Yeah, most of my life.
Yeah, so you'll definitely have a perspective as well, right? How was it for you to move to Android from Java?
To Kotlin, you mean?
Yeah.
Because initially Android I did in Java as well.
Oh, got it. Yeah.
But after I moved to Kotlin, it's like I'm not going back to Java now. It's very comfortable doing Kotlin now.
I used to write code in Java too, but it was many years ago, in the time when I was QA automation engineer at that time. So I was doing Selenium tests in Java. And like now I see, actually, since Kotlin was released, I see how it looks similar to Swift. I've been doing Swift for many years already, and I love Swift and I like Kotlin. It looks similar like a Swift, pretty straightforward, enjoyable language to work with.
Yeah, I actually started out as an iOS engineer, and I was on a team which had Android developers, and I took on the lead role for that and started looking at their PRs, and like I was like, holy cow, it would be really easy to switch over to use Kotlin.
Nice.
They got predicates backwards. One of them did. I'll let you decide. But yeah, that was a smooth transition.
Greg, you have also done iOS as well as Android both, right?
Yeah, for a long time. My first iOS application was in 2009, and my first Android was in 2012. So, and I also learned Java in college back in like the early 2000s. My transition to Kotlin was fantastic. It fixes so much of the problems that a lot of Java had. For a long time, Java was stuck on Java 7 on Android, and a lot of Java 8 with the newer functional paradigms or flow syntax just wasn't there, especially because Android was using the Dalvik build pattern, and also because it was using Eclipse. Remember back before Android Studio exists. But Nikolai's totally right that Swift and Kotlin share a lot of the same principles in their language design. And as developers, we often have to learn new languages or new frameworks, or new things happen. And the industry right now is definitely in a phase where everybody is aligning how they're doing things. Because Jetpack Compose is a lot like SwiftUI, Swift's a lot like Kotlin. There's just it feels like right now the coding industry is maturing itself, where they realized how they all made a lot of mistakes in the 2010s about their languages and their SDKs. And now it's in a much better place, and they look similar because they all learned the same lessons.
Yep.
Well, I want to thank everybody for coming today, both here on the Zoom and on the LinkedIn live stream. We have our summit page link there, which is available for if you want to review any of the information today or take any of the code and play with it. Happy to have you there. And there's also contact information for all of us as well on that page if you want to reach out. Thank you everyone for coming and being a part of this. And I'll hand it off to Parag to give us the final send off.
Thanks, Greg. That was really good. I was really impressed. First of all, thank you all for participating, and special thanks to Jay, Daniel, Satish for putting together this awesome workshop with Greg. And thanks, Greg, for your leadership and doing such an awesome job hosting it. Right, it was really informative. And thank you, Ted and Kayla, both of you, for all your help and making this possible. Today's workshop on KMM, this is a part of the InRhythm Quarterly Summit for Spring 2023, where we are hosting a series of 6 hands-on interactive workshops on the latest technology trends. And our next workshop in this series will be hosted by our Cloud Native Development Practice on April 13th, which is the Thursday of this week, where we will have a hands-on coding workshop on gRPC, which is Google's take on remote procedure calls. And in this workshop, you will learn a brief history of gRPC and the protocol buffers, and then you will build an application to manage nodes powered by Java running in a Docker container. You'll also create a series of CRUD APIs in Java using gRPC to send and receive data packets, translate those into objects, and then store them into a database. It's going to be super informative. I'm super excited about this workshop. Thank you all once again for joining. Have a wonderful evening, and I'll see you all on Thursday.